Hello student, we will discuss about IR spectroscopy. We have already started this topic. So in the last lecture, I have discussed why we use IR spectroscopy, what is its basic principle of IR spectroscopy, why we used this IR spectroscopy. Okay. So in this lecture, I will continue the previous part of the lecture. Okay, so here first I will discuss criteria for a compound to absorb IR radiation. Okay, because we know when energy, the principle of our spectroscopy is when energy in the form of infrared radiation is applied, then it causes the vibration between the atoms of the molecules, and when applied infrared frequency is equal to natural frequency of vibration, then absorption of IR radiation takes place and a peak is observed. Different functional groups absorb different kind of frequencies of IR radiation, hence gives the characteristics peak value. Okay, so therefore IR spectrum of a chemical substance is a fingerprint of a molecule for its identification. Now here in this lecture I will discuss criteria for a compound to absorb IR radiation. Okay, so compound basically absorb IR radiation. After absorbing they are vibrate. Okay, so there are some criteria have for a compound to absorb IR radiation. First is correct wavelength of radiation, and second is change in dipole moment. So what is correct wavelength of radiation? A molecule to absorb IR radiation, the natural frequency of vibration of some part of a molecule is the same as the frequency of incident radiation. Okay, so a molecule, correct wavelength of radiation is a molecule to absorb IR radiation, the natural frequency of vibration of some part of a molecules is the same as the frequency of incident radiation. And second is change in dipole moment. So a molecule can only absorb IR radiation when its absorption causes change in its electric dipole. And a molecule is said to have an electric dipole when there is a slight positive and a slight negative charge on its component of atoms. Okay, so there are two criteria for a compound to absorb IR radiation. First is correct wavelength of radiation. So correct wavelength of radiation, see, a molecule to absorb IR radiation, the natural frequency of vibration of some part of a molecule is the same as the frequency of incident radiation. And change in dipole moment, a molecule can only absorb IR radiation when its absorption causes change in its electric dipole. A molecule is said to have an electric dipole when there is a slight positive and a slight negative charge on its component of atoms. Okay. Now, see, there are two types of molecular vibration. One is stretching vibration and another one is bending vibration. Molecular vibration, if they have these two criteria. Molecules absorb IR radiation if they have these two criteria. After absorbing IR radiation, they show vibration. Okay, so molecular vibration are two types. One is stretching vibration, another one is bending vibration. So what are the stretching vibrations? So stretching vibration is vibration or oscillation along the line of bond. Change in bond length, and it occurs at an higher energy, that means 4000 to 1250 per centimeter. Okay, so stretching vibration occur, vibration or oscillation along, stretching vibration or vibration or oscillation along the line of bond. Okay, change in bond length, Okay, stretching vibration change in bond length, and it occurs at higher energy, that means 4000 to 1250 per centimeter. And this stretching vibration are two types. One is symmetrical stretching, another one is asymmetrical stretching. Okay, so this is symmetrical stretching picture. So in symmetrical stretching, two bonds increase or decrease in length simultaneously. Okay, so stretching vibration are two types. One is symmetrical stretching, another one is asymmetrical stretching. Symmetrical stretching are in symmetrical stretching, two bonds increase or decrease in length simultaneously. But in asymmetrical stretching, one bond length is increased, other is decreased. Okay, they are not increased or decreased simultaneously in asymmetrical stretching. Asymmetrical stretching, one bond length is increased and another one is decreased. Okay, now see bending vibration. There are two types of vibration, stretching vibration and bending vibration. Stretching vibration are two types, symmetrical and asymmetrical. Now see bending vibration. Bending vibration or oscillation not along the line of bond. Okay, we have seen stretching vibration or oscillation along the line of bond, but bending vibration or oscillation not along the line of bond. Okay, these are also called as deformation. In this vibration, bond angle is altered and it occurs at lower frequency 1400 to 666 per centimeter. Okay, and also bending vibration are two types. One is in plane bending. In plane bending is scissoring and rocking, and second one is outplane bending. Outplane bending is wagging and twisting. Okay, so bending vibration is also two types. One is in plane bending and another one is outplane bending. Okay, and in plane bending is also two types. One is scissoring and rocking, and outplane bending is also two types. One is wagging and twisting. Okay, so see, this is in plane bonding. In plane bonding means scissoring bending. Okay, so this diagram represents scissoring in plane bending. So this is an in plane bending. This diagram represents in plane bending. So scissoring is an in plane bending. In scissoring bending, two atoms approach each other and bond angles are decreased. So in scissoring plane bonding, two atoms approach each other and bond angles are decreased. What is rocking bending? Okay, so in rocking, movement of atoms take place in the same direction. Movement of atom take place in the same direction. Here I have mentioned the diagram also. Okay, so see, so this is scissoring bending and this is rocking bending. Now see outplane bending. So there are also two types of outplane bending. One is wagging and another one is twisting. Okay, so in wagging, two atoms move to one side of the plane. Two atoms in wagging bonding, two atoms move to one side of the plane. Okay, they move up and down the plane. But in twisting bending, one atom moves above the plane, another atom moves below the plane. Okay, so in wagging bonding, two atoms move to one side of the plane. They move up and down, but they move one side of the plane. But in twisting bending, one atom moves above the plane and another atom moves below the plane. This is the difference. Okay, now here here I will discuss the instrumentation of IR spectroscopy. Okay, so this picture represent the instrumentation of IR spectroscopy. Okay, so details, so here I have discussed the details of various part of instrumentation of IR spectroscopy. Okay, so first I will discuss the working principle of this IR spectrometer. Okay, so see here, first part of IR instrument. Okay, the instrumentation of IR spectroscopy I will discuss in the next lecture. Okay.